Hello, this is the video for PK relationship practice assignment. In this practice assignment, you will have two information: volume distribution and T-hub. And then based on this information, you will be asked number of questions to calculate. Some of them are conceptual, some of them you have to really do the calculation. Before you do the practice problem, three things you have to know very well. One is V and CL. These are two independent parameters: volume distribution and clearance. CL, two independent parameters. That means change in V does not affect clearance, change in clearance does not affect V. But T-hub depends on the T-hub changes based on V and CL. I think best way what I would do, I would have this table in front of me to answer this question. So it's easy. I have summarized this so that you can answer this conceptual question. So now first question is asking you to calculate clearance. So to do this calculation, you have to use this equation: T-hub is equal to 0.693 V divided by CL. So if you put 0.693 multiplied by 11.5, which is V, and then we know that T-hub is this one. Sorry, we have to calculate clearance. So we have to calculate clearance. So we'll put the T-hub here. You know, this needs to be switched like that. So this will give you a clearance of 1.1 liter per hour. So now you administer a second dose, a second drug which increases the volume of distribution by a factor of 2. That means volume distribution doubles. If you use this equation, think about it. If you use this equation now, you will have, for example, 0.693 multiplied by 11.5 by 2, and then you multiply the half-life. And what is going to be your clearance? If you go back to your calculator, so in that case you will put 0.693 multiplied by 23 is 11.5 multiplied by 2, and then you divide by T-hub 7.22. Sorry, 7.22. So you will have a, you see, this calculation is saying you have a clearance of 2.2 liter per hour. So if you use this equation, this answer is going to be wrong, because change in volume distribution does not change clearance. So always we cannot explain physiological relation with with equation. For this reason you say, okay, volume distribution does not, although increases, clearance does not change. So you are going to put this answer 1.1 liter per hour. Then elimination half-life. Yes, we know from this from that table that elimination half-life is going to change the volume distribution. You see here that increase in volume distribution, T-hub will increase. So now if you go back to the calculation here, T-hub is going to T half will be 0.693 times 11.5 times 2 and divided by the clearance. Clearance is 1.1. So I guess if you go back to this calculator, so 0.693 multiplied by 11.5 times 2 equal divided by, which is clearance is 1.1. You see it is 14.5. So the clearance, the half-life is going to be 14.5 hour. You see, based on that, because volume distribution increases, half-life increases. This equation applies in case of if you want to calculate half-life. But if you want to calculate clearance or volume distribution, this may not work. In case of plasma concentration, in the plasma concentration of kinetomycin at time 0 at C0 after the administration of the same IV bolus dose, what is going to happen? Is it going to plasma concentration? As you remember, how plasma concentration and volume distribution is are related. One thing you have to remember, this is, you have a tank. Think about, you have a water tank. I'm a terrible sketcher. So you have water tank, you have until here water, you put something, you'll have one concentration, but if you double the concentration or double the volume of this water, the concentration is going to decrease. So it will be, initial concentration will go down by a factor of 2. Then what is going to happen to AUC? AUC is not going to change, because AUC depends on, AUC is not going to say, the answer is same, because AUC reflects total drug amount in the body. So it is showing time dependent. So, crush my computer calculation that AUC would decrease by a factor of 2, because volume distribution has increased. When volume distribution increases, sorry, what I'm talking about. Sorry. So AUC is not going to change because AUC reflects total amount of drug in the body, so it's not going to change. So to summarize again, initial concentration is going to decrease by a factor of 2 because volume distribution has increased. When volume increases, concentration is going to decrease. But AUC does not change because AUC reflects total amount of drug in the body. AUC, if you remember this AUC, we calculate everything. So AUC does not change. That's why it's going to remain same. Now let's go to the next problem. So another scenario is coming. If you administer this drug that increases clearance by a factor of 2, what is going to happen? to the following parameters. Volume distribution. What is going to happen to volume distribution? We know clearance does not change with the change in volume distribution, so your volume distribution is going to be the same as this one, 11.5 liter. But elimination half-life is going to change. Elimination half-life will be changing here because clearance has doubled, so T half is equal to 0.693 V divided by clearance. So here in this V and CL 693, in case of V you put 11.5, clearance has increased 2.2, and then if you go back to calculator, this calculator is going to be 0.693 multiplied by 11.5 divided by 2.2, so it's 3.62. So the half-life is going to be 3.62 hours. So what is going to happen? The plasma concentration after administration of the same bolus dose, is it going to be higher than by a factor of 2? Is going to be same or lower by a factor of 2? We know that plasma concentration is not related to clearance. Plasma concentration is related to volume distribution, so they are not going to change. Plasma concentration, when we mean plasma concentration, is an initial plasma concentration. Do not get confused about the plasma concentration changes with time. That means we are talking about the clearance. Clearance is a rate, but when total amount of drug decreases from the body, plasma concentration is going to decrease. But we are talking about initial zero, plasma concentration initial time. So plasma concentration is not going to change because of the change in the clearance. Then AUC value would be higher than by a factor of 2, same, or lower by a factor of 2. So in these cases AUC is going to be lower than by a factor of 2. If you AUC is going to decrease. AUC is going to decrease if you go back to the clearance. With the increase in clearance, AUC decreases. Again, the same reason, AUC reflect total amount in the body, total drug amount in the body. So now you have to calculate the parameters. Assuming dose is decreased by a factor of 2, you just half the dose. What is going to happen to elimination half-life? Elimination half-life, if you double the dose, elimination half-life is not affected by dose. So elimination half-life is going to be the same as, you see, this elimination half-life is going to be same as this one, 7.22. Elimination half-life is not going to change because dose does not affect elimination half-life. Plasma concentration of, what is going to happen to plasma concentration? Plasma concentration, as dose as you have decreased initial plasma concentration, is going to decrease by a factor of 2 because you have just half the dose. Plasma concentration is going to be half 2. And what is going to happen to AUC? AUC is related to the dose, total amount of the drug is going to be lower by a factor of 2. So overall, you have to remember two important concepts, V and CL. I was interrupted by my boss, so I had to stop the video. Anyway, what I wanted to remember, two major concepts that your volume distribution volume distribution, what's going on here? Anyway, volume distribution V and CL are two independent parameters, but T half changes with these two. If you keep in mind, you are going to do perfectly all right. Another thing you have to remember, dose. This dose does not affect T half, no change on T half. And volume distribution, increasing volume distribution, C0 decreases. And it makes sense, always you have to think about this, that volume increase, concentration decrease. That is all I have. I would appreciate any comments, especially comments like, Dr. Asani, I am confused about this, would you elaborate more on this, especially in class? Otherwise, everything looks good. I appreciate listening to these videos. If it helps, it would be a great success for the course and for you. Thank you.